and presentation topic is superconductivity, represented by Asma Iqbal, roll numbers 036, MS Physics section second semester, and presented to Dr. Umesh. The content of my presentation is superconductivity. Superconductivity, history of superconductivity, general principle, classification and property of superconductors, the missner effect and application and conclusion of the superconductors. Now I will discuss about the superconductivity. What is the superconductivity? Superconductivity is a set of physical properties observed in certain materials where electrical resistance, varnish and magnetic flash field are explained from the materials, any materials. And the temperature decrease gradually as the temperature is lower, even down to near absolute temperatures, as the critical temperatures characteristic below with the resistance drop abrupt to zero. As we know that the critical temperature is at the 0 point low. And history of the superconductors, the history of superconductivity is start from the 1911s and discovered by Cameron the superconductors. And after a few years, they used the helium liquefied criticals. 1937, Missner explained the diamagnetic characteristic of the superconductivity, and 1935 theory of superconductivity is given. 1950s Larry proposed a microscope, and the 1957 Barden, Cooper and Skippers published microscopic theory basis of the Cooper pairs information. And 1957 the case he introduced the type of superconductor, two types of superconductors, and after this he discussed about the basic principle of the superconductor. The basic principle of the superconductivity I will discuss about the superconductors principles, which is the current flow with the resistance, and no resistance is little resistance, truly zero resistance, and the conductor system from scattering of the electron of the thermally activity in the ions. The resistance therefore goes down a temperature decrease. Because the temperature decreased in the normal metals, research a minimum based on the impurity in the lattice. And second step, last one step is about the triple R. Triple R represent the residual resistivity ratio. Is the rough measure of the cool work and the impurity in a metals. These are the general principles, and now I will discuss about the classification of the superconductivity. The classification is based on the two step, that is the response of magnetic field and the theory of the operations. About the magnetic field, there is type 1 superconductors, that is single critical field. All superconductivity last and below whose the magnetic field is completely expressed from the superconductor of type 2. There is the two critical field between the partially penetration of the magnetic field through isolated point. These points are called the vertex, and the superconductor is based to have a combination of two behaviors. In case of superconductor is type of second type of the superconductor, and by the theory of operation. In the theory of operations, the BCS theories discussed are its derivatives are unconsciously, otherwise superconductor is called superconducting order parameter transferred from non-trivials to point group of the space group of the system. This is the classification, and next is the critical temperatures and by materials. Critical temperature, the temperatures is change, and the superconducting state above a temperature of 30 kelvins 30 Kelvin initial discovered by Gauge burning and using the superconductivity cooled using liquid nitrogen. This is only Tc greater than 277 kelvins and emphasis liquid nitrogen is sufficient. Low temperature is 47 kelvins. 47 is the high temperature and the low temperature is 42 kelvins, and these are the superconductivities. Some of the group critical temperature below are 30 degrees centigrade. And the material class include chemical elements that are the mercury are lateralized as nobelium, titanium as the type of the materials, that is nitride. Superconductors through graphs are example should be including among the chemical element and the compose of the carbon. Property of superconductor. There are the several properties of superconductors vary from material to materials, and some properties I will discuss about in this presentation, such as the critical temperature, the value of the superconducting gap, critical magnetic field are property independent of the underlying materials. Meissner effect. In the Meissner effect, quantities of the magnetic flux are permanent current, the state of the zero resistance. The existence of three universal properties root to the broken symmetry of the superconductor and the incurge of the diagonals long range, and the superconductivity thermodynamic phase and process certain distance, that is the properties of the superconductors. Now I will discuss about the Meissner effect. Meissner effect is the magnetic excluding of the magnetic field from a superconductor during its transition to the superconducting state. And the superconductors discuss about magnetic properties that are important, and superconductor is not a perfect conductor but a perfect magnetic material with zero electrical resistance is known as the missner effect. As there we discussed zero electrical resistance of the missner effect. These are the missner effect, and the limitation of the missner effect is both penetration depth, type 2 superconductivity, and package vertex. Fourth one is the geometrical effect, intermediate state, and the surface superconductivities. Superconductivities applications are, some of them is the magnetic elevations and magnetic field secured and power transmissions. These are the superconductivities. Superconductivity generators and these are the applications. Next, I will discuss about the conclusion of overall PPT. The superconductivity is one of the important discovery of the field of modern physics. The mentioned property reducing the superconductivity can be classified into different types, and the advantage of superconductivity is their ability of carrying enormous amount of power without loss under critical temperature. So superconductor can save a lot of energy. Thank you for the listening. I hope you will understand about the superconductors. Superconductivity. Thank you.